Functionally, a magnetic contactor is just a giant 3-pole single-throw relay. They both have an electromagnet that pulls two pieces of metal together so current can flow. The difference is contactors are specifically designed for heavy loads like motors, and they have lots of accessories that help make motor control easier and safer. Let's take this one apart so we can see what's going on. If we remove this cover, we can see that the power comes in on these terminals, and when these contacts are pulled down by the big electromagnet in the base, the power crosses over to these terminals. The electromagnet in the base is powered over here on these terminals. Looks like this one needs 200 to 250 volts AC or DC to engage the electromagnet. Some contactors use as little as 12 to 24 volts DC. This contactor also has some contacts on the side. When the main contacts are pulled down by the electromagnet, these contacts are also engaged. You could then connect these aux contacts to a PLC so the PLC can monitor the status of the contactor. You can get a better view of the electromagnet on this smaller contactor. Here's the coil of wire and its terminals. Looks like this one uses 24 volts DC to operate. When the coil is energized, it pulls the contacts down so they make contact and let the power flow across the terminals. When you release power to the coil, the contacts are no longer held down by the electromagnet, and the spring pushes them back up, which cuts the power flow. It's important to distinguish between a contactor and a motor starter. A contactor is just the mechanical switch and the focus of this video. You can use the contactor by itself for small loads, but in industrial applications, you'll probably be using the contactor in a motor starter, which is just one of these contactors with other stuff added, typically overload protection as a minimum. We cover overloads in a separate video, but in general, it's just a device you add in series with the contactor to protect the motor from loads that are too heavy for the motor to handle for long periods of time. You just wire the overload's contacts in series with the contactor's coil. When it senses the overload condition, it kills power to the contactor's coil, which opens the contacts so the motor won't burn itself up. Here's an overload for a WEG mini contactor, and here's one for a Fuji contactor. Again, those are covered in the Contactors Accessories video. Automation Direct has hundreds of contactors. How do you know which one's best for you? The main differentiators are usually how much current they can handle and the cost. If we plot that, we see the WEG contactor family runs from about 10 to 20 bucks and covers 7 to 22 amps. The Fuji family of contactors starts at about 15 bucks and covers 9 to over 300 amps. The GH series contactors start at around $45 and run out to 315 amps. The Eaton contactor family looks a little pricey at first glance when compared to these other guys, but they come with higher-end features like a trip class of 20, which means they'll handle a 600% overcurrent for up to 20 seconds as opposed to the 10 seconds the other guys typically do. And you can purchase the Eaton contactors as full motor starters with the overload included. With the other guys, you need to purchase it separately and build it yourself. So don't shy away from the Eaton just because of the price. If you need the Eaton brand or some of the high-end features they have, definitely check these out. But hopefully this gives you some perspective on where the different families sit. Once you pick a family, then on the AutomationDirect.com website, under Motor Controls, select that family. So select the Fuji contactors, and just work your way down this checklist and narrow your search. Let's see, before any filtering, it looks like we have 158 possible contactors in the Fuji family alone. Coil voltage. We'll control it from a PLC at 24 volts. Then we can pick the current capacity or the frame size. Let's pick the current we need of 32 amps. And just like that, we're down to a single contactor in this family. If you want to, you can do the same thing for the other families and compare. Easy. Other things you'll want to take a look at are agency approvals and durability. That is, how many contact closures can you expect out of this device. It looks like this contactor is rated for about 2 million electrical contacts with as many as 1,800 closures per hour. That's a contact closure every 2 seconds. The mechanicals are rated for over 10 million operations. So if you're only doing a couple motor starts an hour, these things will last a very long time. Which is an important thing to understand about contactors. They will wear out eventually. Each time the contacts open, the current wants to try to keep going so you get an arc. That arc creates pitting and burning on the metal contacts, which eventually stop conducting electricity. So the durability numbers and operating cycles numbers are really important to take into consideration. There's a number of accessories you can get for each of these families, like overload protection, surge protection, latching relay assemblies, reversing kits, aux contacts, etc. Check out the individual videos on these to learn more. Well, that ought to be enough to get you started with Contactors. If you have any questions, please contact Automation Direct's free technical support during regular business hours. They will be happy to help you out. And check out the forum. It's not monitored by the Automation Direct's tech support, but there are a lot of folks out there that love helping people, so don't be shy about posting questions there too.